Till now, you must have heard that the universe can be infighting. Now an infighting is needed, but if the universe is finalized, then it will be of a closed shape. If you go on a tour of the universe, then you will start from the infighting of parabola shape, and you will keep moving forever, and you will never return to the starting point. Whereas in the finite universe, you'll roam around, and one day you will definitely come back to the starting point, as it happens on our finite Earth. But now the question arises that if our universe is finited, or if it is closed, then what will be its shape? Are there holes in the middle of the universe, or is it of a twisted shape like the Mobius strip? And the biggest question is, will we ever be able to know about its shape while living inside the universe? Let me tell you, its answer is yes, this is absolutely possible. And the answer to this question can also solve many of our cosmic mysteries, such as the shape of the universe and how the early universe was formed. Now, Einstein's theory of relativity was created by infighting about all these, and Newton also made his laws on this basis. Similarly, Edwin Hubble also said that the universe is continuously expanding. But its story begins from the 16th century when the scientist, after seeing the red shift in the structure of the galaxy, had assumed that the universe is infighting. But then a turning point came in 1980 when a team of scientists claimed that the structure of the universe is like our Earth, where if we start walking from the North Pole, then after moving around, we would reach the North Pole again. That is, they believe that the infighting theory is wrong. The shape of the universe is somewhat round, i.e. closed like our Earth. But before we know about the shape of the universe, we will have to understand the meaning of the word shape. Now, in this regard, to understand this better, we have to go back to the year 1736. In this year, Leonard Euler started the base of a new field of mathematics called topology. In topology, if anything continuously deforms into another thing, then it is considered equivalent to it. Fold them however you want or drag it. It will always go to the same shape. But you cannot create new holes in it nor close the old holes. That means basically you cannot add or subtract anything from outside the shape. And if you do so, it will be considered a different shape in topology. But here you should not mix topology and geometry because both are different things. Let's understand this with an example. Suppose we have a round circle in front of us, whose radius, diameter, and circumference are. So there will definitely be something that describes its geometry. Now, if we twist this circle a little bit, then its shape and geometry will change, but its topology will remain the same. As I told you earlier, this topology is going to change only then when we tear it or make a hole in it. That is, no matter how much the shape of an object changes, nothing can be added or subtracted from outside in that shape. So basically, topology depends completely on the sides and corners present in the object. There is no hole in the sphere, whereas there is another infighting in a donut. But a sphere cannot become a donut unless we make a hole in it from outside. Now, the thing to understand here is that when we talk about the shape of the universe, it means the topology of the universe. But topology can also be of many types, and being present inside this universe. How will we know what is the topology of the universe? Because we cannot directly observe the topology of our universe. But by doing research on the universe, we can know its topology. We can surely get clues. Now, in comparison to the size of the universe, if we look at black holes, stars, or clusters of galaxies, then their shape can be cupped. You must have seen such a demonstration of Einstein's theory of general relativity, which shows that massive objects like the sun or planets curve the fabric of space-time. Imagine a photon is traveling in space-time, and the photon travels only on the shortest path between two objects, and in normal conditions, this shortest path is always the same. Straight, it's just a line, but if it passes by a massive object, then its path will appear curved to us. This is because that massive object has curved the space-time around it, and this curved path is the shortest path for the photon. You must have seen the path of the photon getting curved. When we observe a huge object far away in the universe, then the galaxy behind it appears distorted to us, which is the result of the curved path of the photon. Let me tell you that in the universe there can be three types of geometry. The first is spherical, like our Earth, then comes flat or Euclidean geometry, and the last is hyperbolic geometry, like any chips that are curved inwards. Some ways to understand these geometries through maths exist. If we draw a triangle on a flat surface, then the sum of its three angles is 180 degrees. But if you draw a triangle on a spherical surface, then the sum of all the three angles will be more than 180 degrees. Whereas for a hyperbola, it will be less than 180 degrees. We can understand this geometry by taking the example of parallel lines. On a flat surface, two lines are always parallel to each other. But on a spherical surface, they merge after going some distance. If we talk about hyperbolic geometry, then parallel lines will immediately keep moving away from each other. But there's a big problem hidden in this analysis, which we cannot understand with our narrow thinking. Look, till now we were talking about a very small scale in comparison to the universe, like stars, planets, or black holes, with the help of which we cannot estimate the shape of the universe. Let us understand this. Imagine that thousands of years ago, three people stood at some distance from each other with a rope in their hands, in such a way that the rope touched the surface but was forming the shape of a triangle. Now, when we measure the three angles of this triangle, then its sum is going to be 180 degrees. So does this mean that our Earth is flat? No, its real meaning is that in comparison to the Earth, our Earth is flat. The scale is very small. If we want to know the geometry of the universe, then we will have to look at something bigger, which is bigger than any star, galaxy, or cluster of galaxies, in which our entire observation can be included, and this is possible only with the cosmic microwave background. This is the biggest picture of the universe, which we can observe and is spread over 1 light year. You can understand it as a picture of the universe when the distance ahead was only 380,000 years. Now, if we look at the cosmic microwave background, it looks quite uniform, despite such a huge distance. But there are some areas which are brighter or dimmer than others, and with the help of these, we are going to find out the geometry of the universe. If the shape of our universe is spherical, then we should see the size of any spot on the cosmic microwave background to be bigger. This is because in such a case, the light reaching our eyes will get warped due to the curving of space, so when we look at it, that spot will appear bigger to us. On the other hand, if the universe is hyperbolic, then this spot will appear smaller to us, and in a flat universe, the size of the spot will be about your actual size. It will be visible in the year 2013. A space telescope named Wilkins Microwave Anisotropy Probe observed these spots of the cosmic microwave background, and its conclusion was that their size appears almost the same as it actually is. So this is the reason there is proof that the geometry of our universe is flat, or maybe very close to flat. But here by flat, I do not mean flat like a paper. Our universe is three-dimensional, and the word flat only defines its geometry. Now, in three-dimensional geometry, flat looks something like this. But if we talk about topology, then according to scientists, there can be 18 three-dimensional topologies in flat geometry. Now, imagine you take a piece of paper and make the shape of a cylinder by rotating it round. And now both the sides of the cylinder stick the corner with glue, and a new shape appears around you, which is called a torus. The thing to note here is that the shape of this piece of paper is changing, but not its topology. Similarly, Mobius strip, and there are also Klein bubbles, which can be the possible shapes of the universe, i.e. topology. Similarly, there are a total of 18 topologies of flat Earth geometry, but can we reduce this number further? Yes, it is absolutely possible, for which we need Euclidean plane and inverse. We have to understand the differences between topologies. On one hand, the Euclidean plane, i.e. a flat surface, and the Klein bottle. All three are finite elements, which represent the finiteness of our universe. For example, if you start walking from a point on a torus, then you will see a slight difference in the distance between the two. After some time, you will reach that point again, and this can be observed not just in one direction, but in multiple directions. Right now, this path might look like a curve to you, but in reality, it's not the path, but the space itself, which is a curve as we saw in the first photon. Here we've seen in the example that we're walking on a curved path, but actually it's a straight line where if we can see far enough, then we can see our own back. I know it's difficult to even imagine this, and scientists also know this. That's why they've told an easy way for this, which is to simply unfold the torus and turn it into a flat plane again, and it's very easy to study things there. Now look at this flat plane, where x and y axes exist, and both of them are folded in the shape of an infighting axis. Then its x-axis will become finite, while the y-axis is still infighting. If you join the ends of the infighting axis and make it a torus, then is our universe really finite, which we know as a torus? We have always been wondering, The answer is quite speculative because sitting inside the universe, we can't even imagine what its actual size is. It's possible that what we consider an observation today is only half or more of the torus that our donor looks like. For the last 2 decades, scientists have been looking for closed loops in the universe, but they have not found any evidence. This can have two meanings. Either the universe is an infoplanet plane with a flat geometry where closed loops are present. Either it does not exist in reality, or it is so vast that light cannot reach us through it till date. Now, due to so much speckle, it was proving difficult for us to know the actual shape of the universe, but recently a team of scientists, whose name is Compact, they have released a surprising research paper. In this research paper, it is said that while trying to understand the shape of the universe, we have become too inclined towards the torus shape and are ignoring the rest of the topology. But any of those topologies can be the probable shape of the universe. Now, this research paper does not solve the mystery of the shape of the universe. But one thing is definitely understood, that this curiosity of humans is not going to be satisfied, and our search is going to continue. Along with this, we also come to know that there is still a lot about the universe about which humans do not know anything, which we will have to explore in the future. So friends, what is your opinion about the shape of the universe? Comment below. I must tell you, and if you like this video, then please like and share this video. Don't forget to share it with your friends, and if you haven't subscribed to our channel yet, then subscribe and turn on the notification bell, because I keep bringing such videos every week. So I will meet you in the next video, and as always, thanks for watching.